Hello friends, welcome to my YouTube channel. Hope you all are doing well. So today is a part 3 of the .NET interview question and answer series. So if you have not watched part 1 and part 2, I'll make sure to put that in the description below so you guys can go and check it out. And also you can click on the right side, and on the I button, so you will be getting the access to part 2. Now this video is going to be a little different, wherein I have also prepared the answer for the questions and I will just briefly touch upon all the answers, and then maybe you can pause the video and then look at the answer and try to understand the code snippets and all. So this is going to be a very interesting video, so be with me and make sure that you watch the video till the end. Do not try to skip any part, because these are some of the questions which, based on my experience, I have prepared, and I think that these are the questions which are most often asked in any of the interviews. So make sure that you be with me and just sit with a pen and paper and keep writing or noting down some of this stuff. And if you guys want this presentation or the slides, just put that in the comment and I will be very happy to provide them as well. So let's move on to the next slide. Okay, so the first question in this series: what is exception handling in general? So explain the try, catch and finally keywords. And there will be a question like, can we have a try block, one try block and a multiple catch blocks? So the answer for this question is, let me try to draw something for you guys. So exception handling is just a mechanism, okay, in any programming language, whether it's C#, it's .NET, Java, right, any programming language. So exception handling means that when some error happens in your application, you want to gracefully come out of that situation, okay. So that is called exception handling, as it's written here. So it allows you to handle any errors or exceptions, or failures gracefully, right? You do not want the actual error to be thrown to the business user. You want to throw some custom error based on the exception occurred, right? Maybe you just want to say that, okay, an unexpected error occurred, right? Or some generic error, you can throw it to the customer. So that's why we use exception handling. Now how exception handling works, let's see a code snippet. Okay, so you can use a try, catch and finally block for handling the exceptions. So in the try block, you put in the code, right, which can possibly throw an exception. So this is the code which can throw an exception, right? Because dividing a 10 by 0, this will throw a divide by 0 exception. So in the catch block, I am catching that specific exception, right? So here you can see I have one try block and I have multiple catch blocks, right? So one catch block is catching a specific exception. Another one is having generic exception block. So this guy handles all other exceptions raised in this try block, right? Hope you are getting it what I am trying to say. So from this specific catch block, you can just send a specific error that, okay, divide by 0 exception has occurred. So divide by 0 exception has occurred, for example. But in this case, since this generic block, you can just write some generic message, right? Okay, an unknown error occurred, maybe from there, right? So you can have multiple catch blocks with one try block, right? Here you can see one catch block, here is another catch block, right? And this finally block, this will be executed regardless of the catch blocks, right? So this is where you can do a cleanup of the code, right? This is going to definitely run, right, this block. So it doesn't matter whether this catch block runs or this catch block runs, this finally block is always going to run. So that's why you can put some of the cleanup code, or maybe removing the connections or something, right? And then your other code continues. So hope you guys got it. Let's move on to the next slide. Okay, so what is a middleware in .NET framework? And then what are custom middlewares? Can we create our own custom middleware? And you may be also asked that give a code snippet of creating a custom middleware. So what is a middleware? So as it's written here, middleware refers to a components or softwares that sits between the application request and response pipeline. So when you make an HTTP request, right, so in between there is a middleware which is sitting. This guy is the middleware in between, which is responsible for handling the request and response pipeline. Okay, and then you get an HTTP response here. So maybe your middleware, for example, your authentication middleware. So once a request comes, HTTP request comes, the authentication middleware will try to make sure that the request passes through the authentication, right? And then the request further passes to the authorization, right? So these are the middlewares which are sitting in between the request and response processing pipeline. Okay, now yeah, you can create your custom middlewares and then you can also register them into application builder and then you can use them. So let's see a code snippet for the same. So this is the pipeline where you want to register it, right? Or this is the middleware where this is the middleware which you want to register in your pipeline, which I have shown you in the next slide here. So hope you got it. Now let's move on to the next slide. The next question can be, what's the difference between app.Use and app.run middlewares, right? Can we chain multiple middlewares based on conditional logic? Yes, you can chain multiple middlewares based on conditional logic. Now what is the difference between app.Use and app.run? So both these app.Use and app.run, they are used to add middlewares to the request processing pipeline, right? But they do have some of the behavior which is not common. So they differ in the behavior. So app.Use method also adds a middleware, app.run also adds a middleware to the request processing pipeline. But the thing is, with the app.Use, this can pass on to the next middleware as well. So this guy, when you say app.Use, right, and then just maybe say use logging, for example. Okay, so this guy will internally, after calling this middleware, it will pass on the control to the next middleware in the pipeline. So it will call the next middleware in the pipeline. Okay, but with app.run, what happens is that this is kind of a terminator of the request processing pipeline. So this is the last middleware which will be called app.run. Okay, so this guy does not call a next middleware. So this is just the end of the middleware processing pipeline. So that's why it's written here, middleware added using app.run is the last middleware which is executed in the pipeline. Okay, so let's move on to the next slide. So let's see a code snippet for app.Use and app.run. So you see here on my application builder interface, I have a variable app. So I'm using app.Use developer exception page, app.Use exception handler, right? App.Use middleware. So this guy will pass on the control to the, because we are using app.Use, so this does not terminate the middleware pipeline. This just passes the control to the next middleware, right? And this again passes to the next middleware, right? This again passes to the next middleware. Now app.run is the last middleware in the pipeline. So this is just the termination, right? When you register something in app.run, after this there will be no middleware in the pipeline which will be called, right? So this is the last one. Hope you got the answer. Now let's move on to the next slide. Now this is very basic question, but whenever I take interviews, I ask guys, but they are not able to explain me properly. Sometimes people say that entry point in the applications of .NET is startup.cs class. So that's where I thought like, okay, I'll put up this question here. So when you are asked like what is the entry point in applications of .NET, so your program.cs is the entry point in the application. This class, this is the entry point of in your applications of .NET, and this has a main method, right? So main method will be the first method which will be called inside the program.cs class, and then from here you create a host builder which starts the ASP.NET Core on the web server, right? And then here you use the startup class in webbuilder.use startup, and then the control goes to the startup class. In startup class, you then again have your iConfigure services method where you do dependency injection, right, on this interface. And then you have iApplication builder, and then you have iConfiguration to fetch all the configurations from app settings, right? Hope you got what I am trying to say here. Now let's move on to the next slide. So next question can be, what are filters and attributes in .NET, and how do you create a custom attribute? Now there are some default attributes which you have seen, right? Authorize, API controller attribute, right? Now what's the use of attributes? So these are the set of questions which can be related to filters and attributes in the interview. So attributes, as you know, they are mechanism to add some metadata or behavior to a code elements, right? Such as types, methods, or properties. So for example, when you create a controller class, right? A controller class. So you annotate this controller class with API controller attribute, right? API controller attribute, if you remember, right? So this attribute has some built-in functionality, right? Which provides some of the executions to happen, right? Or some of the metadata which you can get via reflection, right? So this is a like convenient way of achieving something, right? Very, very handy way of achieving something with the attributes. So as it's written here, they provide a way to annotate code elements with additional information that can be inspected at runtime using reflection. Now same thing with filters. Filters are also kind of implemented as attributes only, right? Which allow developers to apply them directly to controllers' actions. So filters can be used for logging, caching, authorization, exception handling, etc. Right? Now let's see an example how this attributes and filters can be used. Okay. So to make your custom attribute, what you need to specify is you need to create a class, custom attribute, which inherits a system, defined class called attribute in .NET, right? So this is given by .NET framework. So you need to inherit attribute class. Okay. Now you can define the properties or fields for the attributes. So I have one property which is defined as name. Now in the constructor, I am just initializing this attribute. So maybe I'll pass something when I use this attribute, right? I'll just pass maybe my name, Ashish, right? And how I'll pass it? So I'll just name, like when I want to use this attribute, how will I use it? I'll just say custom, and then in brackets I have to pass the name here in the constructor. So I'll just say Ashish. Okay, and this way I can use this attribute on any of the where all I can use this attribute. So you can specify here that attribute usage, right? This attribute can be used on class level. This attribute can also be used on the method, right? And allow multiple equal to false means that you cannot specify the same attribute multiple times on the class, right? So I cannot ideally use the same attribute again on the same class, right? Custom, and then maybe say Ashish. I cannot do this, right? It does not allow multiple. That's why I have said it as false. Okay, hope you got it. How you can create your custom attributes, right? It's very simple, nothing rocket science here. So let's move on to the next slide. So the next question could be, what is the lazy loading, right? And why is it so much helpful? How do you achieve lazy loading? Okay, so in the name itself, it says, right, lazy loading. Lazy means that, okay, something which is not very proactively done, right? It is happening maybe at a later point of time. So in the language of .NET, lazy loading means that some things which are not needed to be initialized at the compile time, right? So it can save a lot of memory and resources, right, when your application starts to build up. So the benefit of lazy loading is that it can improve the performance as mentioned here, right? So by deferring the loading of resources until they are needed, right? So when the resources are needed, then only you want to initialize them, right? So it improves your application startup time, and it also reduces the memory usage. So, and it also ensures that only this necessary data is loaded into memory, right? Rather than loading all resources upfront, correct? So you do not need to load everything which is not needed on the startup. Suppose for example, whenever you want to make a connection to DB, you just initialize at that moment, right? So that you can do lazily. So you have to take a call in your applications wherever you want to implement lazy loading, right? It can reduce the resource consumption, right? It can optimize user experience. So just take some time and maybe go through these points which I have just put in here. In the interest of time, I would like to move on to the next slide. So next question can be, what is a null coalescing operator? So null coalescing operator is very simple. This is denoted with this, right? 2 question marks. This is called null coalescing operator. So using this operator, you want to assign a default value if the name is null. So where you can use null coalescing operator, where if for example you have a default name here, you have given a default name. So in a case like when this variable is null or value of this variable is null, I would like to give it a default name, right? So this is a handy way of assigning a default value using null coalescing operator. Now let's move on to the next slide. So next question, which is very important: what is multi-threading and parallelism? Explain the difference between them. So this is a very important question to discuss here, because this is mostly asked in all of the interviews and people get confused because these terms sound similar, right? Multi-threading and parallelism, but there are very thin line of differences which we need to understand here. So I'll just highlight some of the points. So multi-threading refers to the ability of a single process. This is very important. It's ability of a single process to execute multiple threads concurrently. So process will be one, right? This will be P. Now this will be executing multiple threads concurrently. So T1 thread, T2, T3. Okay. What is a thread? Now thread is the smallest unit of execution within a process. Okay. This is the smallest unit of execution. So we call that as a thread. Okay. And multi-threading allows your program to perform multiple tasks simultaneously. Okay. By dividing the workload among multiple threads. Okay. In multi-threaded application, multiple threads run independently within the same process, as I have discussed here, right? They run in the same process, but each thread had its own execution path and perform tasks currently within other threads Okay. Now in parallelism, what is the difference is, the major difference is that on the tasks or the threads, right, will be broken down into smaller sub-threads or subtasks, and they will be executed parallelly on different processors of CPU. So there is P1 processor, P2, multiple cores, P3 at the same time, right? But in case of multi-threading, they will be executed on same process, right? So that's the major difference, that in this case they will be executed on different processes in parallel, okay, on different processes, P1, P2, P3. But in multi-threading, only one process, but which is concurrently executing multiple tasks or threads, right? So take some time to read through this and hope you understand it. Now let's move on to the next slide. Okay, the next question is, this is very important question, like what are async and await keyword? How do you achieve asynchronous programming using these keywords? Yeah, as in the question itself, I have written that these keywords are used to achieve asynchronous programming in your application. So async keyword is used to define asynchronous methods, right? So an asynchronous method is a method that can perform asynchronous operations without blocking the calling thread. So whenever you want to achieve asynchronous programming in C# or .NET, you mark that method with async. So for example, async do some work, then maybe it takes input parameter, input A, right? So inside async, this parameter is marking the method as asynchronous, right? So it will not block the calling thread. And then you want to await for, so async and await keywords are used in conjunction with each other, right? So async and await keywords, they both will be used together. Okay, so you can maybe await on an HTTP call here. For example, I'm just giving an example here. So let's talk about await keyword. Now await keyword is used to asynchronously wait for the completion of an asynchronous operation. So you want to wait, right, till the operation is complete. So you can use await keyword, or else what will happen is that the control will, before getting the result itself, the control is gonna perform another task, right, which is here, the next line of code. So if you are dependent on the input, right, in the next step, so you want to await, right, once you obtain the result here, then you want to move on to the next step. So you can just wait for the process to complete asynchronously using await keyword. So when you await an asynchronous operation, right, the calling thread is not blocked. Instead, the control returns to the caller. Okay, and the thread can perform other work while waiting for the asynchronous operation to complete. Now let's move on to the next slide, where I will just show you a code snippet how the async await keywords are used. So if you see here, I have a main method and I am using an HTTP client to call an API. Okay, now you mark your method with async keyword, right? So this, when you mark a method with async keyword, this signifies that this is an asynchronous programming. Okay, and then you want to get some results from the API call. So you ideally use await keyword to not block the calling thread and return to the caller, right? So you use the await keyword so that the calling thread can perform other things, right? It's not hanging the application for the user. It's giving a nice experience to user. And once this task is complete, it will just assign the response here in this variable. Now you want to ensure that response was successful. So you make sure that response.ensure success status code, and then you asynchronously read the response content, right? So again, you use the await keyword and read the content as a string. Okay, and then you are doing a console.write line here. So just take some time, spend some 5-10 minutes and go through these codes, maybe copy and paste these and just try to run the output and see the output, right? Let's move on to the next slide. What is a task keyword? So the next question is, what is a task keyword? So task is a class in .NET framework which represents an asynchronous operation. Okay, so this class itself represents that this is an asynchronous operation which can be executed concurrently. Now let's talk about some of the points about this class. So task is a fundamental type used in asynchronous programming in C#. It represents an operation that can be performed asynchronously. Okay, so it represents any operation which is performed asynchronously. Now parallelism. The task class can also be used for parallel programming, because you can use task parallel library, right? There is a TPL called task parallel library, where you have some methods provided by .NET framework like task.when all, task.wait all, right? So these are like some of the extension methods or execution methods which you can use on task to manage multiple tasks, right? You can even create your own tasks and manage them using task parallel library, right? So let's move on to the next slide. Maybe you guys also try to implement some code snippet or make an example code snippet where you implement task keyword, right? So I'll move on to the next slide. Now the next question could be, explain me about threads and how will you create multiple threads and how then you will be going to invoke them. So in .NET, threads are the smallest, or not in .NET, maybe in another language as well. The concept remains same. Threads are the smallest unit of execution within a process. So they enable concurrent execution of multiple tasks. Okay. So you can create thread T1 equal to new thread, right? So this is a way to initialize a thread. So they enable concurrent execution of multiple tasks, allowing a program to perform multiple operations simultaneously. Threads share the same memory, space, and resources within a process, but they have their own execution context, including a program counter stack and a set of CPU registers. So let's move on to the next example of using a thread. So here I have a main method and I create and start multiple threads. So this is a way to create a thread, and then I want to invoke a thread using anonymous method here, using this one, what is called lambda expression, and I am calling one method print numbers, and this is the print numbers method which just loops in through the numbers start and end, right? So I have created two threads here, and then you want to do start, right? So how you start a thread? To start executing in parallel, you can say thread1.start, thread2.start, right? So there's a start method which is used for starting a execution. Now you can use thread1.join, thread2.join to wait for the both threads to complete, and then you can print a message that okay, all threads have completed. So this is the way how you initialize a thread and how you invoke a thread, right? And then how you can wait for threads to complete. Now let's move on to the next slide. Now next question can be, what is a cancellation token? So the cancellation token, you might have seen that this cancellation token term is being used in the code with the async await keyword, right? With asynchronous programming, async await keyword methods. So the methods which are marked with async and await, you might have seen that okay, this cancellation token is being used or passed as a parameter to these methods. So this is a mechanism provided in .NET Framework to facilitate cooperative cancellation of an asynchronous operations. So for example, if there is an asynchronous operation which is going on, and then you may want to just wait for 5 seconds, and if you do not see any result in 5 seconds, you may want to send a cancellation to an asynchronous operation. So you can use this cancellation token class, right? So this gives you flexibility where you want to give the caller the ability to cancel long running operation such as a task or thread in a graceful manner. So as I told you, this is mostly integrated with async patterns like async or await keywords. Cancellation tokens seamlessly integrate with asynchronous programming patterns such as async await pattern. Async methods can accept a cancellation token as a parameter. So how it will be, like for example, let me just write you a pseudo code for you. So maybe I'll say public, maybe async some method, right? Public async, let me say void, does not return anything, and just say input, it takes integer a, and maybe I'll just pass in. So how you pass in? A cancellation token CT, right? So whenever some guy calls this method, he can ideally pass a cancellation token source here. Okay, and then how you pass the cancellation token source? You can use cancellation token source equals to new cancellation token source. You initialize and in this class, cancellation token class instance, and then maybe you just say that cancel after 5 seconds. So there are methods provided where you can define the timestamp, like I want to cancel after 5 seconds or milliseconds. So you can use that value here, like if cancellation is requested, then cancel the asynchronous operation. Hope you got what I am trying to say here. So spend some time and maybe do not just stop here. Maybe try to find some other references and explore a little bit more. So the next question is, what is the difference between IEnumerable and IQueryable, and why do we use both of them? So the major difference between IEnumerable and IQueryable is that both are the interfaces which are available to work on the collections, right? So IEnumerable is basically used to work on the collections which are available to you in memory, right, or they are available to you locally. And IQueryable interface is basically used to work with the data sources, external data sources. For example, fetching some data from DB, fetching some data from files, fetching some data from XML sources, right? So that's where you use IQueryable. Now, this IQueryable also provides you a rich set of queries, right? So you can have some complex queries built in on IQueryable interface and access the data from remote sources. But this functionality is lacking in IEnumerable interface. And also IQueryable supports deferred execution. So it can allow query operations to be composed and deferred until the query results are actually needed. And the good thing is that both IEnumerable and IQueryable, they both support LINQ. So you can write very concise and precise query expressions in C# or maybe other .NET languages like F# or something. So maybe just practice a little bit of coding snippets on IEnumerable and IQueryable interface, and you are good to go. The last question in this series is, what is iCollection interface? Okay, so this interface in .NET it represents non-generic collection of objects that can be individually accessed by index, and this also has a lot of methods like add, count, okay, remove. And this I collection, it internally inherits I enumerable interface. Okay, so non-generic collections, it is being used to work on the non-generic. Non-generic means array list, for example, right, where you do not have the type of the data, the data type at the compile time. For example, like list, right, list T. This is a generic collection, right? Non-generic means that the type of collection objects which do not have the data type at the compile time. So this you can use this interface to work with such collection objects which are non-generic. Okay, like hash set, right, queue, stack, array list. Now I have got you one example where the I collection interface is being used. So let's move on to the next slide. This is an example. As you can see here, I have a main method and then I create a new array list which implements I collection. So this is a variable I collection which is of type I collection. Now you want to add some elements to the collection. This is a new type of array list. Okay, so I am initializing array list here, and then you can use add method of I collection to add apple, banana, orange, right, where your data type is not defined. So you can add. So this does not have the type checking, right, in place. So this lacks type checking flexibility. So you can use these methods on I collection, like you have add method, then you can have a remove method to remove the items from the collection, and then you can also count the number of items in the collection object using collection.count. So just this is what I have today in this video, and if you like my content, please do like, comment, share and subscribe, and do not forget to share it with your friends as well. So see you in the next video. Thank you. Bye bye.